Welcome to Too Easy to Learn. Learn with Mr. Big. Today's topic is surds. Arithmetic operation on surds. In this lesson, students will be able to define surd, simplify a surd, add and subtract surds, multiply and divide surd. Let's start our lesson. What is a surd? To understand this concept, let's discuss few examples. What is the square root of following numbers? Square root of 4. What do you think? What should be the square root of 4? Think. It is 2. 2 is an integer. What is square root of 25? Think. It is 5. 5 is also an integer. What is square root of 121? It is 11. And 11 is also an integer. What is square root of 196? 14. And 14 is also a square integer, an integer. So 4, 25, 21 and 96 are called perfect square numbers because the square root of a perfect square number is an integer. So all these numbers are perfect square. Let's discuss one more concept. What is the square root of the following numbers? Again, square root of 2. Square root of 2 is an integer or not? Think. You can check it on your calculator. If you find the square root of 2 on your calculator, you will see the answer is 1.414 and so on. So 1.414, it is non-terminating decimal, is not an integer. Square root of 5, check it on your calculator. 2.236. It's also non-terminating decimal. And square root of 11. What do you think? Its answer should be integer or not? No. The answer is 3.316. It is not an integer. Square root of 19. 4.358. Non-terminating decimals. So these numbers 2, 5, 11 and 19 are not perfect square numbers because the square root of these numbers are not integers. So these numbers are called surd. The square root of 2 is a surd. Square root of 5 is a surd. Square root of 11 is a surd. Square root of 19 is a surd. Why? Because their answers are not integers. These answers are irrational numbers. So we can say surds are the values in the square root that cannot be further simplified into integers. A surd is an irrational number. Let's practice to identify which number is surd and which is not a surd. We have a list of numbers and identify a surd and not a surd and put it in right column. Before deciding, you first think the square root of that number is an integer or not. If it is integer, it is not surd. And if it is not integer, it is surd. So what do you think? Square root of 4? Answer is 2. It is not surd. 125. Think about it. The 125 square root is an integer or not? No, it is a surd. Square root of 12. You should think its square root is integer or not. No, then it is a surd. Square root of 64. Its answer is 8, and 8 is an integer, so it is not a surd. Square root of 8. Its answer is not integer, so it means it is a surd. 225. Think about it. Its answer is an integer or not, so it is not a surd. Square root of 400. Its answer is 20, so it means it is not a surd because 20 is an integer. Square root of 72. Its answer is not an integer, so therefore square root of 72 is a surd. The surd is a number whose square root is not an integer, and not a surd is a number whose square root is an integer. I hope by this practice you can differentiate between a surd and not a surd. How to simplify a surd? It's a very basic important concept because this will be applied in higher order questions as well. So learn it carefully. What is meant by simplifying it? Let's discuss with an example. Square root of 50 is a surd. What you need to do, you need to divide this 50 into two factors. The one factor should be a perfect square and the other factor should not be a perfect square. Can you think which two numbers are the factors of 50? One is perfect square, another one is not a perfect square. Yes, 25 times 2. 25 is a perfect square number and 2 is not a perfect square number. So we can take the square root of 25, which is 5, and we'll keep the 2 under the square root. You can split it in two parts. Square root of 25 times square root of 2, and square root of 25 is 5. So your final answer is 5 times square root of 2. So simplifying surd is where we rewrite a surd in its simplest form by ensuring the number underneath the root sign has no square number as a factor. So let's discuss more example to clear this concept. Square root of 45 is a surd. Now split this number in two factors. One should be a perfect square and other should not be a perfect square. Think about it. Yes, 16 times 3. So 3 times 16 is 48. 16 is a perfect square number and 3 is not a perfect square number. Split in separate roots. Square root of 16 is 4 and this is a surd, square root of 3. So final answer is 4 times under root 3. Square root of 16 is 4. Let's discuss one more example. Oh, it's a very big number. So it is hard to think about what should be the factors. One should be a perfect square number and other should not be a perfect square number. So then what should we do? It is hard to split mentally. So we have one way, one method to get its factor, prime factors. So make prime factors of 405. So you must have this good skill. It's very important skills making prime factors. So if you look at all these prime factors, multiply these numbers. 3 times 3 9, times 3 27, times 3 81. Is it 81 a perfect square number? Yes. So 5 is not a perfect square number. So if you don't get the factors mentally, you can make prime factors, and from prime factors you can get a perfect square number and not a perfect square number. So 81 times is 405. Now write in separate roots. 81, square root of 81 times square root of 5. What is the square root of 81? It is 9. So final answer is 9 times square root of 5. Square root of 5 is a surd. Now let's discuss arithmetic operations on surds. So we know that there are addition, subtraction, multiplication and divisions. These are 4 arithmetic operations. Let's discuss addition and subtraction of surds. Like terms are added and subtracted. Like in algebra, we can add and subtract the like terms. Same, like surds can be added and subtracted. Let's discuss this example. 2 times square root of 5 plus 4 times square root of 5. So square root of 5 is a surd. These both surds are same. 2 is a coefficient of this surd and 4 is a coefficient of these surds. These are the same surds, we can add it. So 2 plus 4 is 6. So final answer is 6 times square root of 5. Let's discuss one more example. 8 times square root of 3 negative 6 times square root of 3. So square root of 3 and are the same surd, so we can subtract it. So 8 minus 6 is 2. So final answer is 2 times square root of 3. Oh no, what is this? These are big numbers and these are not same surds. Square root of 98 negative square root of 32. So in previous examples the surds were same, but here they are not same. So what you need to do? You need to simplify it first. Let's simplify square root of 98. You need to think 2 factors of 98. One should be a perfect square and other should not be a perfect square. Think about it. Yes. So 49 times 2 is 98. So 49 is a perfect square number and 2 is not a perfect square number. Think about 32. Split in 2 factors. Yes, 16 times 2 is 32. 16 is a perfect square number and 2 is not a perfect square number. Now simplify this. What is the square root of 49? It is 7. So this simplified answer is 7 times square root of 2. And what should it be? Square root of 16 is 4. So it should be 4 times square root of 2. Now we have like terms, square root of 2 and square root of 2. So coefficient of this number is 7 and coefficient of this surd is 4. So 7 minus 4 is 3. So your final answer is 3 times square root of 2. Multiplication divisions of surd. If there is a multiplication sign between 2 surds and the roots are same, like it is square root of 5 and it is square root of 2, then we can write both numbers under same root like this. So 5 times 2. So 5 times 2 is 10 and the final answer is square root of 10. Let's discuss one example of division. Square root of 15 is a surd divided by square root of 3 is also a surd. If the both roots are same and there is a division sign between these roots, you can write under same root. So 15 divided by 3 is 5. So your final answer is square root of 5. So there is a drill sheet. You can practice all these concepts by solving these drill sheets. Thank you. See you in next lesson.